LangGraph's asynchronous streaming mechanism enables real-time token-level filtering of LLM outputs through metadata-driven conditional logic. This artifact demonstrates how to initialize tagged LLM instances and selectively stream tokens based on invocation metadata during graph execution. The code will reveal a dual model setup where each LLM is initialized with distinct tags, followed by an asynchronous streaming loop that filters and prints tokens exclusively from the joke-tagged model invocation.
From LangChain, chat models import init chat model. Hash model 1 is tagged with joke. Model 1 equals init chat model equals GPT-4. 1 mini tags equals joke. Hash model 2 is tagged with poem. Model 2 equals init chat model equals GPT-4. 1 mini tags equals poem. Graph equals hash define a graph that uses these LLMs. Hash the stream mode is set to messages to stream LLM tokens. Hash the metadata contains information about the LLM invocation, including the tags. Async for MSG, metadata in graph a stream. Topic, cats. Stream mode equals messages. Hash filter the stream tokens by the tags field in the metadata to only include. Hash the tokens from the LLM invocation with the joke tag. If metadata tags equals joke. Print msc content end equals flush equals true.
This code demonstrates async streaming of LLM tokens with selective filtering based on model tags. The pattern uses LangGraph's aStream method with stream mode equals messages to receive real-time token streams from multiple LLM invocations, where each model is initialized with specific tags, joke, and poem. The async iterator processes each token metadata pair, filtering output by checking the tags field in metadata to only display tokens from the joke-generating model. The approach enables concurrent LLM execution while maintaining clean output separation, crucial for applications needing to handle multiple specialized models. By tagging models during initialization and filtering during streaming, developers can manage complex multi-model workflows without mixing outputs. This pattern is particularly valuable when different models serve distinct purposes in the same pipeline, though it requires careful tag management to avoid collisions. The async implementation ensures non-blocking token processing, which is essential for responsive UX in real-time applications. However, this comes with the trade-off of increased complexity in Python versions below 3.11, where explicit, runnable config passing becomes necessary for proper context propagation. The filtering mechanism adds minimal overhead while providing precise control over which model outputs reach the user. Let's break it down.
From LangChain, chat models import init chat model.
Imports the init chat model function from LangChain's chat models module, providing access to chat model initialization capabilities.
Hash model 1 is tagged with joke. Model 1 equals init chat model equals GPT-4. 1 mini tags equals joke.
Initializes a chat model using the GPT-4, 1 mini model, and assigns it to the variable model1, while tagging it with the label joke for categorization or filtering purposes. The tags parameter provides metadata that can be used to identify or group models by their intended use case.
Hash model 2 is tagged with poem. Model 2 equals init chat model equals GPT-4. 1 mini tags equals poem.
Initializes a chat model using the GPT-4, 1 mini model, and assigns it to the variable model2 with the tag poem applied for categorization or routing purposes. The tags parameter suggests this model instance is specifically designated for poem-related tasks or content generation.
Async for MSG, metadata in graph a stream.
iterates asynchronously over messages and metadata from the graph's streaming output. The aStream method yields tuples containing the message content and associated metadata as they become available, allowing real-time processing of the graph's execution results.
Topic: cats.
Creates a dictionary entry with the key topic and the value cats. This represents a simple key-value pair where the topic is explicitly set to cats.
Stream mode equals messages.
Sets the streaming mode to messages for the current operation, indicating that the output will be delivered as a sequence of discrete message objects rather than a continuous stream or other formats. This parameter controls how data is chunked and transmitted during streaming operations.
Hash filter the stream tokens by the tags field in the metadata to only include. Hash the tokens from the LLM invocation with the joke tag. If metadata tags equals joke.
Filters the stream tokens by checking if the metadata's tags field contains exactly the list, joke. This conditional ensures only tokens from LLM invocations tagged as jokes are processed further.
Printmsc content end equals, flush equals true.
Prints the content of MSG, content to the console with a pipe character, at the end instead of a new line, and forces immediate output without buffering. The flush equals true parameter ensures the output is written immediately rather than being held in a buffer. Tagging models during initialization and filtering their outputs during async streaming creates a clean separation of concerns in multi-model workflows. The tags parameter in init chat model serves as metadata that travels with each token through the streaming pipeline, while a stream with stream mode equals messages enables real-time token-level processing. The conditional check on metadata tags acts as a lightweight router, ensuring only joke-tagged content reaches the output. This pattern balances flexibility with control. Models run concurrently without output interference, but require disciplined tag management to prevent collisions. The async implementation keeps the pipeline responsive, though it introduces complexity in older Python versions where context propagation needs explicit handling. By combining tagged initialization with metadata-driven filtering, you get a scalable way to orchestrate specialized models while maintaining clean output streams.
The stream whispers joke tokens, but only the tag list giggles in silent metadata.